Okay, we're doing here today Unit 2, Lesson 5 homework, page 88, numbers 1 through 3, and 8 and 10. Here I have number 1 on the board already. It gives you the situation here. It says solve for x, where HGJ is congruent to ONP. So here's HGJ, and this is congruent to ONP. So these two angles here are going to be congruent. The next thing it tells me is that GJ and NP are bisectors, are angle bisectors, which means this ray here and this ray here both break both these angles in half. So if this is congruent to that, we know that this side is also congruent to this side because a bisector divides an angle exactly in half. Whatever this has to be the same. So I can make that symbol there as well. And I can say this one is exactly congruent to this one as well. I'll make that symbol there too. Okay, so now we know everything here is all congruent. We want to know that if HGK is 50 degrees, this is HGK, if this whole thing here is 50 degrees, and O and R, this whole thing here is also 50 degrees, we know that these two must be congruent. We learned in class today about the multiplication property. If I double an angle, and I double its congruent angle as well, the two doubles must also be congruent. So I go ahead and put those together and say that this is 50 degrees, which we call here 2x plus 10. So I would say 2x plus 10 is equal to 50 degrees. Right? This is 50, but it's also 2x plus 10. So now I just have to go ahead and solve for x. I subtract 10 from both sides. I get 2x equals 40. Divide both sides by 2, and I get x equals 20. Now here in part B, it tells me that SW is congruent to SZ. So here's SW here, and this whole thing here is congruent to this whole thing there. It also tells me that TZ and BY trisect SW and SC. So this part here, this is a trisector, and this is also a trisector. So this piece, and this piece are all exactly congruent. And this piece, and this piece are all exactly congruent. And again, we learned about the division property, that if I divide in half, or in 3 here, my segments which are congruent, then the divisions will also be congruent. So if I know that, if it says ST here equals 12, what is YZ? YZ is x minus 4. And again, I know that all parts of these 3 and all parts of these 3, all 6 little segments must be congruent. So I go ahead and say that x minus 4 has to be equal to 12. Every single one of these guys must be 12. This one's 12, this one, and if this is congruent to that, the small pieces are also. So this must also equal 12. And here again, I just solve for x. I add 4 to both sides, and I get x equals 16. Okay, here's problem 2. Given DF is congruent to GJ, so this is DF, and this is congruent to GJ. These two lengths are both congruent. And E is the midpoint of DF, and H is the midpoint of GJ. So here's E is a midpoint, and we know midpoint breaks the segment into 2 equal pieces. So if this is the midpoint, this must be congruent to that. And H is the midpoint of GJ. So here the midpoint again breaks into 2 congruent pieces. This must be congruent to that. I want to prove that DE is going to be congruent to GH. Maybe you can already start seeing that what we learned in class. Here we have 2 congruent pieces, and they're both divided in half. Our division property says that those equal divisions will also be congruent. So that's what we're going to do here in a proof statement. So let's write our statements and reasons. And our number 1, we're going to write down our givens, that DF is congruent to GJ, and that E is midpoint of DF, and H is midpoint of GJ, and our reason there is given. And then our second step here is to go ahead and say that the small piece will also be congruent because of the division property. If I take 2 congruent pieces and divide them in half, the half piece will also be congruent. So we're going to write that here. DE is going to be congruent to GJ, GH. And the reason for that is the division property. Right, and we prove that this is congruent to this, DE and GH. Okay, here's problem number 3. It says given KMR is congruent to LTW. So this one is KMR is congruent to BTW. So I can draw those tick marks there. And I know that MR and NP trisect KMO. So MR and NP are trisecting this, which means that all three of these are going to be the same, right? And I know that TZ and TW trisect STV, TX and TW are both trisecting STV, so that means all these are going to be the same. And now we're going to prove that KMO, this whole angle, is going to be congruent to STV. And again, we're going to use the multiplication property. If I have two smaller angles that are congruent, and then I triple them, because I see this is just 1/3 of the whole thing, these are trisectors, so all three are the same, then the bigger angle must also be congruent. So we're going to write that out in a table proof here. So we have our statements and our reasons. So we start out by telling our givens. We know that angle KMR is congruent to angle VTW, and we know that MR and MP are trisect angle KMO, and I know that TX and TW are trisecting angle STV, and all that is given. Great, so now I go ahead and prove that my last step here, just two steps here, angle KMO, which is the bigger angle, must be congruent to the other bigger angle STV, and then we're going to use the multiplication property. We're going to triple each one of these, and we'll call this here the multiplication property. Okay, and that's it. Let's go ahead and do number 8 now. Okay, here's problem number 8. We have the chart here, and we have the picture here, and we have two givens. We want to go and fill in the chart. We don't have to build the chart ourselves from the picture here. So our first given was VW is congruent to AB. That's here. VW is congruent to AB, and our reason is given. Right, I write out the givens for you, but you can see in the book. We're on page 92 now. And WX is congruent to BC is also given to us. That's saying here this WX is congruent to BC. And now I want to say that VX, this whole segment here, is congruent to this whole segment here, AC. And we can do that with the addition property, because I'm adding two congruent segments. Right, these are congruent to these, and these are congruent to these. When I add them together, that's our addition property we saw before. So that's addition property. And now my other two givens was Z is the midpoint of BZ, that was given. X here is the midpoint of BZ, so this has to be the same as this. And C is the midpoint of AD, so AC must be congruent to CB. That's again our definition of midpoint. These two things were given. And I know that VX is congruent to AC because I just proved that with the addition property. So now I want to prove that VZ is congruent to AD. VZ is congruent to AD, and I can do that with the multiplication property. When I double this and I double this, they're both congruent. Their doubles must also be congruent. That's our multiplication property. Multiplication. Okay, and here's problem 10. I drew the pictures for you on the board, and we'll write our statements, and here are our givens. So our given is that PR bisects QPS. PR bisects QPS, angle QPS. So that's your PR is bisecting QPS. So this is going to be the same as that, because here this ray is bisecting. And our second given is that KO bisects angle JKM. Angle JKM. So here's angle JKM, and here's KO bisecting. So this part here must be congruent to that part there, because a bisector divides an angle in half. And my last two givens is that angle 1 is supplementary to angle JKM, and that angle 1 is also supplementary to angle QPS, angle QPS. And all of these here are given. And that's important to us. So we're saying this figure angle JKM is supplementary to angle 1. If I add angle 1 and this angle, I'll get a straight line. I'll get a 180 degrees. And if I add this angle QPS to angle 1, I'll also get a straight angle of 180 degrees. So a theorem we learned before was that if I have two angles that are both supplementary to the same angle, then they must be congruent. Whatever you say this is, these two have to be the same. If this is 100, these are both 80. If this is 90, these are both 90. Right? It has to add up to 180. If this is a 30-degree angle, these two must each be 150 because they're both supplementary to this angle here. So let's go ahead and say that now in our proof. I want to say that angle QPS must be congruent to angle JKM. And the reason for that is two angles that are supplementary, two angles that are supplementary to the same angle are congruent. Another congruent sign. And now our last step, now that I know that these two are congruent, I can go ahead and say that angle 2 and angle 3 are also going to be congruent because half of this and half of this will be the same because of our division property. Two angles are congruent, so half of those two angles will also be congruent. So that's step 3 here. Right, we're finally making our proof. Our goal is to prove that angle 2 is congruent with angle 3. And I'm able to do that with my division property.